All right, welcome back. This is the makeup video for the E-Day on Wednesday, February 12th, 2025. We are covering lesson 4.2, which is all about the general addition rule. And we're going to dive into what we're really talking about there. Yesterday, we talked about the theory involved behind just probability in general. What does it mean when we say that there's a blank % chance of something? Does it mean that we're guaranteed to have so many successes in a finite number of attempts? And we learned that probability is much more general than that. It's not really certain. We always have to do things in really, really large numbers to ever get kind of a good sense that anything's probably going to be some way that we expect. And once we have that grasp of what probability is, then we can start to learn some of the rules behind it. So today we are doing that using this backdrop of kind of the taco tongue and the evil eyebrow. So we're collecting data on two kinds of things that you might be able to do with your face. Taco tongue, this picture isn't the greatest, but it's like when you can curl your tongue in a loop like that. And then an evil eyebrow, that's where you can put one eyebrow down and one eyebrow up. It's kind of like the rock face. So what's interesting is some people can evil eyebrow, some people can taco tongue, some people could do both, and some people can do neither. So normally we would collect our class data about, who can do both and do those surveys. For today, we are going to do just last stats class, so fall of 2024 stats class, and see what they were able to do. Out of that class, there were 8 who were able to taco tongue and evil eyebrow. 7 were able to taco tongue but not evil eyebrow. 1 was able to evil eyebrow but not taco tongue. And then we had 3 that were not able to do either, so no evil eyebrow and no taco tongue. To understand our probabilities a bit more, we can add up the totals across the rows and across the columns. And this is something that we're going to do on all two-way tables. This is called a two-way table because we have data on 2 variables. One variable is on and really they're events with probability. One event is on the rows and one event is displayed on the columns here. So if I add these up, the probability of just being able to taco tongue, or the number of people who could just taco tongue, would be 8 plus 7. So there were 15 people in general who could taco tongue. 1 plus 3 is 4 people who could not taco tongue. 8 plus 1 is 9 people who could evil eyebrow. And 7 plus 3 is 10 people who could not. That means in total, we can add down here, so 15 plus 4, there were 19 people in total who voted. And if I look across the columns, that's true as well. 9 plus 10 is 19. Out of that, we can define these events using the same kind of letters we used yesterday. So instead of saying yes, taco tongue every time, maybe I could call taco tongue T. Let's do that in blue, T. And that would make no taco tongue the complement of T. So T and then with a little C next to it. Evil eyebrow we could call E. And then no evil eyebrow would be E with a little C next to it. We can also express these things in a Venn diagram. So our Venn diagram has 4 basic areas. I think the easiest area to understand is the area where we have both. So this is everybody who both can taco tongue and can evil eyebrow. And that would be the 8 people that are in the top left over here. The way that we write that, using our probability notation, that would be E, and then we do a little symbol like that. It's an upside down U, E and T. The way I remember that is like mac and cheese means mac and cheese. And this little N here means both E and T. We also have yes, taco tongue, but not evil eyebrow. So yes, taco tongue, no evil eyebrow was 7. So this would be E and complement of T in that box. We have yes, evil eyebrow. So yes, evil eyebrow, but no taco tongue. There was only 1 in that group. And then outside of both circles, we have anyone who could do neither. So that was 3. So suppose we randomly choose a student from the class. We're going to find these following probabilities as fractions. So the probability that someone could yes, taco tongue would be, again, remember how we find probabilities. It's the number of desired outcomes out of the number of total outcomes. In this case, all of our outcomes are students. So there are 15 students who could taco tongue, and there are 19 students total. And we're leaving these as fractions. Yes, evil eyebrow. Go ahead and you can pause the video or fast forward if you want to do this on your own. But that would be 9 out of 19 because 9 people could evil eyebrow out of the 19 total. No taco tongue, 4 out of 19. No evil eyebrow, so no evil eyebrow would be 10 out of 19. And then we have both taco tongue and evil eyebrow would be 8 out of 19. Yes, evil eyebrow, no taco tongue, 1 out of 19. Yes, taco tongue, no evil eyebrow, 7 out of 19. No taco tongue and no evil eyebrow would be 3 out of 19. Okay, suppose that we randomly choose a student from class. We're going to find these probabilities as fractions now. So the probability of yes, evil eyebrow, we already found that one. That's 9 out of 19. The probability of no evil eyebrow is 10 out of 19. We already learned that and word. So and means both. But here, now we're looking at yes, evil eyebrow, or no evil eyebrow. And what that or word is going to mean is either or. So anyone who could either evil eyebrow or anyone who could either not evil eyebrow. So I think of this as an either or situation. So when we say this, this might sound a little silly, but to find these probabilities, we're just going to add them together. So 9 out of 19 plus 10 out of 19 is 19 out of 19, which is just 1. What this is getting at here is these two are called mutually exclusive events. It is impossible to both evil eyebrow and not evil eyebrow at the same time. You can't do it, right? Either you can or you can't. In other words, the probability of yes, evil eyebrow and no evil eyebrow is 0 because there is nobody who would be able to be in this category who can somehow both evil eyebrow and not. That's going to be 0. So no one can do both. That makes it mutually exclusive. When events are mutually exclusive, we can find the probability of one or the other just by adding them up. So if I were to write these out, like up here, we have yes, taco tongue, and no evil eyebrow. Remember, our symbol for and kind of looks like an N. So taco tongue and no evil eyebrow would be the complement of E. We could have this one, probability of no taco tongue would be TC, and no evil eyebrow EC, E complement. Well, down here, when we're trying to write an OR probability, we write the OR using just a normal U. So it's like the AND symbol but flipped over. So yes, evil eyebrow, or no evil eyebrow would be E complement, like that. So remember that kind of that N looking one means and. Think of like mac and cheese, mac and cheese. And then the or is just the odd one out. It looks like a U, and that just means or. So and means we're doing both events at the same time, or means we could do either event. So think in your Venn diagram, and is where we have specifically both, or is when we have any part of either circle. Let's see what happens when we want to find a more meaningful OR probability. So the probability of yes taco tongue. Probability of yes taco tongue would be 15 out of 19. All right, 15 people could taco tongue out of the total 19. Yes evil eyebrow would be evil eyebrow, 9 total out of 19. And so if we're following the prior rule, we can just add those probabilities together to get the probability that someone can taco tongue or evil eyebrow. So this would be 15 plus 9 over 19. And, oh wait. Remember, our probability was supposed to be a number, from 0 to 1. But that's not from 0 to 1. That doesn't work. We've messed up here. So when I look back up at my table, we did the probability that someone could taco tongue. So it was this cell and this cell to get 15. But then we added the probability someone could evil eyebrow. So it was this cell plus this cell equals 9. So all we're interested in is the probability we get someone who can either taco tongue or evil eyebrow. And the problem is, if you noticed, we counted this and box where people could do both. We counted it twice. So these events over here were not mutually exclusive. So what that means is that someone is capable of both being able to taco tongue and being able to evil eyebrow. Someone can do both at the same time and have that ability. So when events are not mutually exclusive, we cannot just add their probabilities together. Cannot simply add together. What we need to do, remember we double counted that box with both. We need to take one of these boxes away. So when events are not mutually exclusive, we use what's called the general addition rule. And that's where we take the probability of one event plus the probability of the other event. And this is all to find the probability of either A or B. And remember, this wasn't good enough because we double count this box. So to find the true probability of one or the other, we have to subtract one of those boxes. Because if we double count it, when we subtract one, we'll have only the one left over that we need. So we actually subtract the probability of both A and B. So instead of doing 15 plus 9 up here, instead we want to do 15 plus 9 minus the probability of both, which is actually 8 out of 19. So 15 plus 9 is 24, minus 8 is 16 out of 19. That is a good probability. That is going to be the probability that out of last semester's stats class, if I randomly selected one student, there was a 16 out of 19 chance that that student could either taco tongue or that they could evil eyebrow. So general addition rule is kind of the center focus of what we just did. On to our notes today. We've got a couple things to think about. First, we have that two-way table. Two-way table is maybe a more efficient way of organizing our data than like a Venn diagram would be. So let's do a two-way table on the left and a Venn diagram on the right. And our Venn diagram does need a box around it. Okay. So on our two-way table, we're always going to have two events. We'll have A and the complement of A, B and the complement of B, and then we usually always take the totals so we could find those useful probabilities, like what's the total probability of A regardless of whether or not B happens. We're always going to have some sort of counts in these boxes. I'm just going to label them. All right. If we're in the top left, this is both A and B. So in our Venn diagram, that's where the two circles are going to intersect. The other easy one on the diagram is if we have neither. That's going to be outside the circle entirely. I do need to label each of these circles, so A and B there. Okay, now 2 is A but not B. So 2 is going to be in the part of A that does not touch B at all. And then 3 is going to be in the part of B that does not touch A at all. So that's how we kind of organize our two-way tables and our Venn diagrams. I'm just going to make a note here. Find your totals. So add across the rows, add down the columns, and especially this number right here that you get when you add up the totals, that is an important number because if you wanted to find like the probability of both A and B, it would be the number in this box divided by the number total. All right, number 2 over here. This is for our general addition rule. And the general addition rule states that the probability of an event A or B is equal to the probability of A plus the probability of B minus the probability of both A and B. This U stands for union, but really it means or. So that's how we use it in probability. This N is really for intersect. Again, we don't really use it like that. We think of it as and. So like the N in mac and cheese. So the N looking symbol, that means and. If you can remember that, then the other one just means or. So what this means is we can find the probability of either one or the other just by adding their probabilities together and then subtracting the probability that both happen. Make another note here. If the events A and B are mutually exclusive, that was a new vocab word, mutually exclusive, they can't occur together. So it's like impossible. It's like on a survey, asking someone if they're a man or a woman, right? You can't be both, hopefully. So probability of A, and it would look like the probability of both A and B equal to 0. When the probability of both A and B is equal to 0, then this general addition rule gets a little bit simpler. So if they're mutually exclusive, and this is a special part of the rule, this is like an exception, then it's just the probability of A plus the probability of B. However, if you don't know if they're mutually exclusive, then you've got to keep this in mind. You've got to have A, B, and the probability of both. Let's go ahead and apply that. A random sample of high school students was surveyed regarding their procrastination habits. The two-way table displays the results. Suppose we choose a member of the sample at random. Define events X as yes to take an AP class and Y as yes to procrastinating often. Explain in plain language what this means and find the probability. So this is the complement of Y. So remember, Y would be that the student says yes to procrastinating often. So if they're in the complement of that, that means they don't procrastinate often, or at least they say they don't. So in plain language, this would be probability of Y complement would be the probability of selecting a student who did not say yes to procrastinating. Okay? Number 2, explain why the probability of either X or Y does not equal the probability of X plus the probability of Y. And then they want us to go ahead and find it. Well, before we do that, it is probably useful to find these totals on the two-way table. So let's tackle that first. 58 plus 12 is 70. 24 plus 22 is 46. So that means there are 116 students total. 12 plus 22 is 34. And then 24 plus 58 would be, let's see, 82? Yeah, 82. And that would add up. Okay, we have our totals. Now let's think about this. So what they're saying is, if I wanted to find the probability that someone either is taking an AP class or procrastinates often, why can't I just add them together? Well, look at what that would mean. The totals here, this is where we find the probability of, this would be Y and Y complement. This would be X and X complement. So the probability of Y would be 82 out of 116. The probability of X would be 70 out of 116. To get those, we added up this row and this column, and then we'd be double counting that procrastinate often and take an AP class. So this is back to our general addition rule. The probability of A plus the probability of B minus the probability of both. So we can't do this because the events are not mutually exclusive. The probability of both X and Y does not equal 0, meaning X and Y are not mutually exclusive. So to find either X or Y, that probability, we are going to do the probability of X, which is 70 out of 116, plus the probability of Y, which is 82 out of 116, minus the probability of both, 58 out of 116. So 70 plus 82 minus 58 is 94 out of 116. Let's go ahead and find the decimal of that. That would be 0.8103. Make a Venn diagram to display the results. So remember, with your Venn diagram, start with a big rectangle covering up everything, and then make your circles inside. We'll do X over here and Y over here. The people who can do both go in between, so that'd be 58. Then we had some people who could do Y but not X, so that was 24. We had X but not Y was 12. And then outside we have 22 people who can do neither, or who are neither taking an AP class nor procrastinating. And lastly, write the event does not procrastinate often and is taking an AP class in symbolic form. So, probability does not procrastinate often. That would be Y complement. And then we have X for taking an AP class. The symbol for and, remember, is the one that looks like an N. So this would be the probability of Y complement and X. All right, that is all I've got for you for notes today. Let me know if you have any questions just by email or Canvas message. Have a good day. Bye.